Hello everyone, this is Pratibha from Sri Venkateswara College of Engineering. In this video, I am going to discuss about insertion sort from the subject is Design and Analysis of Algorithm. Today's agenda is Introduction to Insertion Sorting, the basic algorithm of insertion sorting, advantages of insertion sorting, limitations of insertion sorting, best case, worst case and average case time complexity, example of insertion sorting with demonstration, conclusion and key takeaways. Next, we move on to the introduction to sorting algorithms. What are sorting algorithms? Sorting algorithms are the set of instructions used to arrange the data elements in a specific order. The algorithms are widely used to across a variety of fields, including computer science, statistics, and operations research. Why are sorting algorithms important? Sorting algorithms play a circular role in optimizing search algorithms, making them faster and more efficient. They can also help to improve a database management, scheduling, and a number of other applications. Types of sorting algorithms. There are many different sorting algorithms, including selection sort, bubble sort, and quick sort. Each algorithm has its own strength and weakness, depending on the size of the data set, the structure of the data, and the desired outcomes. What is insertion sort? How it is works? Insertion sort consists of inserting each element in the right place, shifting the larger elements to make room depending on its position. Each naive element in the list may require shifting several elements. Definition of insertion sort. Insertion sort is a simple sorting algorithm that builds the sorted list on item at a time. It is much less efficient on large lists than more advanced algorithms such as quicksort, mergesort, or ipsort. For example, suppose we have unsorted list of numbers 5, 2, 1, 9, 7. We start with 5 since it is the first element. Next, we perform the insertion sort on the second element 2. By comparing it against the first element and inserting at the correct position, we continue this process until the element has sorted. The basic algorithm of insertion sorting. Pseudocode. For each item in the list, compare it with the item to its left, moving larger items along until a smaller item is found. Insert the item here. Algorithm. Pick the first unsorted element. Compare the element to the sorted elements to its left to find the correct spot. Shift all sorted elements that are larger to the right one position. Insert the unsorted element in the correct spot. Here are some advantages and disadvantages of insertion sorting. Advantages. Simple implementation. Insertion sort is relatively easy to understand and implement compared to more complex sorting algorithms like merge sort or quick sort. Efficient for small listers. Insertion sort performs well small listers or nearly sorted data. It has a low constant factor and works efficiently when the input size is small. Adaptive. Insertion sort is a adaptive, which means it becomes more efficient when dealing with partially sorted data as it requires fewer comparisons and swaps. Disadvantages. Inefficiency for large listers. Insertion sort time complexity is order of n square in the worst case scenario, making it inefficient for larger listers. This is this is because it compares and shifts elements one by one. Not suitable for large scale sorting. Due to its quadratic time complexity, insertion sort is not suitable for sorting large data sets. More efficient algorithms like merge sort or quick sort are better choices for such cases. Lack of parallelism. Insertion sort is inherently sequentially in nature. It doesn't naturally lend itself parallel processing like some other sorting algorithms, which can take advantages of modern multi-core processor. In summary, insertion sort is a simple and adaptive algorithm that works well for small or nearly sorted lists, but it becomes inefficient for larger lists due to its quadratic time complexity. Limitations of insertion sorting. Not efficient on large data sets. Insertion sort performs quickly degrades on large or entirely unsorted data sets. Inefficient of search-based applications. Searches need a high degree of randomness in the data for better performance, but insertion sort can't guarantee that. Stability is dependent on the implementation. Different implementation can cause more movement of items and result in loss of order among same value items. The time and space complexity analysis. Time complexity. The time complexity of insertion sort is order of n square, where n is the number of elements in the array. This means that for large arrays, insertion sort can be very slow. Space complexity. The space complexity of insertion sort is order 1, meaning it requires a constant amount of extra space of the algorithm. Best and worst case of insertion sort. Best case is order of n. The best case of insertion sort when the list is already sorted. In the case, insertion sort has a time complexity of order of n, which is the best possible time of a sorting algorithm. Worst case is order of n square. The worst case of insertion sort when the list is in reverse order. In the case, insertion sort has a time complexity of order of n square, which makes it very efficient of large data sets. Next is average case time complexity. Order of n square. Quadratic time but performs better than other algorithms when the data is partially. Pros and cons of insertion sort. Pros: simple and easy to understand, low memory requirement, best case time complexity of order n. Cons: worst case time complexity of order of n square, unsuitable for large data sets, less efficient than merge sort or quicksort. We move on to the conclusion of insertion sort. Key takeaways. Insertion sort is a simple and easy to understand sorting algorithm that can be efficient for small data sets or for data sets that are nearly sorted. Where the data algorithm can take long time to execute for larger data sets, so it may not the data best choice in such case. Final thoughts. Overall, sorting algorithms are essential tools in a wide range of fields and applications. By understanding how they work and their strengths and weaknesses, we can better use them, manage and analyze data effectively. Thank you for watching this video.